So last year on Pi Day, I didn't make a video because I didn't really know what to make. And 1 year fast forward, it's 2019 Pi Day, and obviously the original video I wanted to make failed. At the last second, I decided, hey, I have a really cool watch, and why not calculate pi on my CA53W-1? Because I need an excuse to actually use my calculator on my watch. So here's the video. I hope you enjoy. Okay, so this is Exhibit A, Weierstrass definition of pi. Well, we know that this is pi because the indefinite integration of 1 over root 1 minus x squared to the dx is arc sine x. But since we're gonna use our handy dandy CA53W-1, yes, that's right, I'm recording this at 3 a.m. We can't just use the integration directly. So instead, we'll be using this, the Simpsons Rule. So this is a way of approximating an integration using this formula over here. And I won't go into the proof, we'll just use it right away. So for the Simpsons Rule, I'll have to choose an even number n. I'll use 18. Why not? It's a fairly large number. 1/3 times 1 over 9. So basically you can see here that I did this thing. Ignore the multiply by 2 for now. I used the Simpsons Rule, which I showed just now. But the thing is, what should have come after this one is plus 2 times 1 over root 1 minus 1 over 9 squared. But that value is equal to this one. Ignore the multiply by 2 on the side. That was because the camera did not record. The plus or minus value inside the squares don't really matter. And basically what I'm saying is this integration is double the integral of 1 over root 1 minus x squared from 0 to 1. So basically, since those values would be the same, I just multiply by the 2. Since this is the center value, it doesn't matter. It's just 1. But another issue arises where this one is gonna become 2 over 0, which is like infinity or something. So that's an issue. I'm gonna do this instead of this. I'm just gonna do 2 over a smaller value of 0, 1, and I'll go with 2 over 0.1. I apologize if it's terrible. I don't know what else I'm gonna do. Also, since we're gonna use my calculator watch, we're gonna need a formula that can approximate a square root, which I was able to find on Brilliant, not sponsored. P is the greatest perfect square less than n, and Q is whatever left to fill in the gap. And this is basically terrible looking, jeez. So this is basically the approximation. But since most of these are less than 1, it's basically the approximation is just going to equal itself. Anyways, whatever. I'll just calculate it and then we'll see what we get. Basically, I was able to simplify the above into these fractions. And I guess all that's left is for us to calculate. Okay, so this should look prettier than what I had before. Ignore that. Although since all of these fractions inside the square roots are smaller than 1, that means p has to be 0, meaning the approximation for us is basically just q, since these are just 0. So the approximations just come out to be these guys. So I guess we're gonna have a terrible approximation, but we can go ahead and finish this anyways. We get to use our calculator. I don't know how I'm gonna be able to do this. Jeez. 2 divided by 0.1. Let's just test it out. I know. I think this is the equal sign, 20, yeah, so it works basically. Yeah, okay. Clear it. So we next have 8 over root 17 over 81. So basically the approximation would just come out as 8 over 17 over 81. So that should be 8 times 81 over 17. Let's try that out. 81 divided by 17. Okay. Okay, I think this is about right. I'm not sure if it's right or wrong. If you see a mistake, then feel free to comment down below. I'm it's too late right now, so I'm just gonna go ahead with these calculations. Next up, I'm gonna add all these numbers up. Equals. Okay, so those are all the numbers added up. Now we just have to divide it by 27. 4.42. That's the new value of pi, everybody. What a terrible number. 4.420. So this was Exhibit A, the Weierstrass definition of pi. You can feel free to use this if you actually have an actual scientific calculator or something, but not if you just have a four-function calculator, because this is a terrible idea. Okay, so Exhibit B, the Gregory Leibniz series. This is quite a popular one. You know, you've probably already seen a lot of YouTubers do this. It's 4 times 1 minus, alternating minus plus minus plus, and on the bottom of the fraction you get the odd numbers. So it's pretty simple. And okay, so let's see, pi equals, okay, so we've got 4 minus, let's just do it all at once this time. Okay, so we'll leave it at 17 right now. Why don't we just add deduct all of them right now. So 4 minus, okay, and reset. Okay, so it's a lot more accurate this time, obviously. Well, yeah, so this is a lot more accurate, still a little off, but this one wasn't that hard. It was just inputting into the calculator. So why not move on to something a little bit more difficult? Here we have Exhibit C, the Chudnovsky formula. 5, 4, 5, 1, 4, 0, 1, 3, 4. Well, okay. That's a problem. Yeah, there's not enough spaces on my calculator watch. Well, screw it. Can't do this one, sorry. No Exhibit C. Okay, so I didn't want to leave it off right there. This is Exhibit D. When Euler solved the Basel problem, he was able to establish a connection between pi and prime numbers. And apparently it helped contribute to the Riemann zeta function, so I put it there, but yeah, I don't know what I'm talking about here, so don't take it for granted. Basically, what we should focus here is this area right here, which is pi squared over 6 equals, well, the sum of the fractions with the squares of the numbers on the bottom. I also want to try out the square root approximation for real instead of just, letting p equal 0. So again, this shouldn't be too complex, but we'll do the first 18 as just like before. 1/4, 1/9. Okay, so we've got the first 18 terms, and then I guess we should add up all these guys. I guess I have to turn all these into decimals and then add them all up. I'll skip this part as well. Okay, so I got the number finally. So we can get pi squared is approximately 1.5901114. Oh shoot, I think there was another 4 behind it, but let's just go with that for now. I'm pretty sure that was another 4. So let's multiply that by 6. We get 9.5406864. Let's double check this time. Yeah, okay. Root pi simulator, approximator. And we can guess that the approximation of pi should be, p should be 3, 9 in this case. So it's 3 plus 6 plus 1, 7, and then on the top we have 0, 6, 4. So let's see what comes out. 0.5406864 divided by 7 plus 3. Not that great. What was the other one? Let's see. Where did I put it? Exhibit B. So we had Exhibit B with 3.25. We had Exhibit A with 4.4 something here. The last one. I don't know what the official name of this one is, but this infinite series right here turned out to be the most accurate one, I guess. So, thanks for watching then. This has been a video of me trying to trying to calculate the value of pi just using my 4-function calculator watch. And I'll see you guys in the next video. See ya.